Hello and welcome. You are going to look at example problems. That will be a review of algebra, helping you for some pre-calc stuff here. Let's go right to them. See how fast we can go. Number 1, graph 2x squared plus 9x minus 5 is greater than 0 on a number line. First thing I'm going to do is find the critical points. So I'm going to set this thing equal to 0. I'm going to solve for x here, and then I'm going to test to the left and right of my critical numbers. That's all I got to do. So solving for x, is it factorable? I think it is here. 2x, x equals 0. Positive 5 over here, so 2x times 5 would be 10x. Minus 1x is 9x. We're good. Okay, so there's the factored form. If you work on factoring as you need to. This was my mental approach. So zero product property. Either 2x minus 1 equals 0, or x plus 5 equals 0. So 2x equals 1, and x equals 1/2, or x equals negative 5. So here are my two critical numbers. This is where this parabola intersects with the x-axis, y equals 0. And we got to figure out the points that I plug in for x that will be above the x-axis. So I'm going to test points to the left and right of the numbers 1/2 and negative 5. So here are my two critical numbers. Let's do negative 5 first. Right there. Let's test to negative 5's left. Let's try like negative 7. Between negative 5 and 1/2, it would be 0. How about that? And 1/2, let's do 1 greater than it. Negative 7 squared is 49. 49 times 2 is 98. Negative 7 times 9 is negative 63. 98 minus 63 is 33. 33 minus 5 is 28. That is greater than 0. It's a positive number. That will be a part of our solution set. Anything less than negative 5 for x will give you a y value that is positive. 0 plus 0 minus 5 is negative 5. That is negative. That is false. 1 squared is 1 times 2 is 2 plus 9 is not 9 is 11 minus 5 is 6. Positive, true. So anything greater than 1/2, anything less than negative 5 will satisfy our solution set. 1/2 and 5 will not satisfy our solution set because if I substitute 1/2 or 5 into this inequality, I'm going to get 0. And 0 is not greater than 0, so 0 is not a part of the solution set. So let's go ahead and graph this solution set on a number line now that we know what it is. I like to put 0 there still. Here's 0, here's 1/2, okay. Here's negative 5, way over there. Doesn't have to be way drawn to scale, but don't want like negative 5 right there, right? It's kind of weird. Open circle, both ways, and that's our solution set. Anything in between negative 5 and 1/2, including 5 and 1/2, negative 5 and 1/2, would not satisfy the inequality. Number 2, find the equation of a line given negative 2, 8 and slope negative 2/9, then graph using m and b. So they say graph using m and b, which means we got to kind of use y equals mx plus b form when we find the equation of the line. Looks like we need to end on this. Doesn't mean we need to start on that. Now you may, and there's no problem with it. So most people, when they have this set, they do one of two things. One of three things. Either they freak out. Either they start with point-slope form, or they start with slope-intercept form. I'll start with point-slope form first. Personally, I tend to almost never use point-slope form, but some people do. So, and here I'm going to get it in slope-intercept form. I'm going to distribute the negative 2/9 in for x and for 2. And I'll get negative 2/9 x minus 4/9. Add the 8. 8 is 72 over 9, if I still remember some of my division. So that'll be negative 2/9 x, and 72 minus 4, that's a negative, is 68. So plus 68 over 9. So that's mx plus b form right there. Not very beautiful because 68 over 9 can't even reduce, much less is not an integer. So you can use point-slope form and solve for it, or slope-intercept form. You'll get to the same answer. Just kind of start a little sooner. I'm going to write y equals negative 2/9 x plus b. I'm going to substitute negative 2 for x and 8 for y. And well, once again, you're doing the exact same work here. Sorry, negative 2/9 times negative 2 plus b. 8 equals positive 4/9 plus b. Subtract 4/9 from both sides. So negative 4/9 plus. And as we know, 8 was 72 over 9. Negative 4/9 plus 72 over 9 is 68 over 9. So once you get 68 over 9 as your b value, you go back to this y equals mx plus b, you substitute it right there, and you get the exact same equation right there. So there's our mx plus b form. We're going to graph using that. I'm very angry and upset that they made us graph using that and not using our x1, y1. See, I wouldn't mind using point-slope form in graphing, but they said no. So let's go up to 68/9. Now, what is that number? Well, 63 over 9 is 7. 72 over 9 is 8. So it's going to be between the numbers 7 and 8, almost right down the middle. 5/9 of the way up from there. 6, 7, and boom. About halfway up, just a little bit more than halfway up right there. I don't like graphing using a y-intercept fraction and going down and over, but hey, whatever. Let's go down 2 over 9. How about that? 1, 2, and 9. I know these graphs because I've kind of made them like this. 9 is all the way. It's the last one you can see. 10 is like the one you can't see over there. It's negative 2 over 9. And here I can also go up 2 over 9. 1, 2, and all the way over to 9, which is over here. Now, these are on fractions here. Another point that is on this is negative 2 comma 8. So up here. So if you'd like, I guess you can also use these points. Negative 2, 8. And from here, I could actually find another point by going down 2 over 9. 1, 2, 3. Right here. So here are some other additional points on the graph just to be a little bit closer to what I want. So here we go. Draw that line. Let's go about like that right there. That's good. So there it is, using the slope and y-intercept, and we found it. Number 3, find the distance between the following 2 points, negative 2 comma 8 and 5 comma 4. There's a thing called the distance formula, which is really derived from Pythagorean theorem. And Pythagorean theorem comes into play from right triangles. So what I'm going to do, my very quickest method that I love, is here's negative 2, 8. Whoop-de-doo. Here's 5, 4. Right there. Not perfect, but the whole point sometimes, especially when you're doing slope or something, is you want to say what your roundabout as far as what your triangle should look like, what else there. Now I'm going to go vertically down in the y direction. I'm going to go from 8 all the way down to 4. All the way, it's not really a large set. Going down from 8 to 4, it takes 4 steps to do that. It takes 4 units, right? The distance is 4 away. Going across from negative 2 to 5 is 7 away. So the distance between the two, if I use Pythagorean theorem here, I can call this one my C or my D or my R, just whatever it is. I'll call it D. Pythagorean theorem. 4 squared plus 7 squared equals d squared. Now, when you do distance formula, you're subtracting, you're doing x2 minus x1 squared and y2 minus y1 squared. You're going to get these numbers, or even a negative version of them. But the good news is, when you square them, they become positive. So d squared is 65. So d is the square root of 65, which I believe does not simplify, because that's 5 times 13, and those are prime numbers. So that's it. That's the distance between them. If you round to the nearest tenth, it's something else. It's a little more than 8. Say 8.1 something, 8.2 something, I don't know. But square root of 65. Number 4, find the midpoint between the same points. Thanks to myself not bringing them over. Negative 2, 8, and 5, 4. Here's actually what I'm going to do. Because you're doing it on the same, you're probably doing these back to back here. I'll have the same luxury of doing it back to back. I'm going to transfer this work over there. The good thing about doing this way, not just plugging things in, is at least you know what you're talking about with it. So I got options. I may either take the average of the numbers negative 2 and 5 and the numbers 8 and 4, and you'll find your midpoint, which is completely valid, completely sane. But because I have some work here, I'll take half of these distances, and I'll just add or subtract them from one set of numbers. So if I'm going from negative 2, 8 to the midpoint, then I'm going down in the y direction, which means I'll subtract half that value. I'm going to the right in the x direction, which means I'm going to add half that value. half of 4 is 2. Half of 7 is 3.5. So when I'm finding my midpoint, I can do negative 2 plus 3.5 because I'm going 3.5 to the right. And I can go 8 minus 2 because I'm going 2 down. So those numbers are 1.5 and 6. So that's one way of finding the midpoint. I can also do the exact same thing from these 2 points right here. This is going 3.5 to the left, and this is going 2 up. So from the points 5 and 4, I can do 5 minus 3.5 because that's to the left. And I can go 4 plus 2 because that's up, which is 1.5, 6. If you'd like to do the midpoint formula, average your x values, negative 2 and 5, and average your y values, 8 and 4. Negative 2 plus 5 is 3. 8 plus 4 is 12. 3 halves is 1.5, 1.5. 12 over 2 is 6. So 2 different approaches. One branches off into 2 different directions right there. And then there's the averaging one right there, which is midpoint formula. x1 plus x2 over 2, y1 plus y2 over 2. Number 5, solve 14 plus 2 over x minus 1 equals 10. One way to do it is just find a common denominator for everything. But because I can combine like terms with the 14 and the 10, I'm just going to go ahead and subtract 14 from both sides here. I can show you the other way because I don't know. Let me quickly advance a little bit. Okay, I don't know if I run into another rational one here, so I'll do a common denominator one as well in just a bit here. So I'll get 2 over x minus 1 equals negative 4. Now this is negative 4 over 1, so you could do cross multiplication, but I'll do what the exact same thing is of that, multiply both sides by x minus 1. These go away. I have 2 equals negative 4x plus 4. If I subtract 4 over here, I'm going to get negative 2. Over here I get negative 4x. I divide both sides by negative 4, and I'm going to get x equals negative 2 over negative 4, which is positive 1/2, positive 0.5. Now, you want to double check for extraneous solutions, which means if I substitute 1/2 into here, will I divide by 0? No, looks like 1/2 minus 1 gives me negative 1/2. That's not an issue. If I got x equals 1 as a solution, I'd have to cross it out because it's not, because that would be an extraneous solution. You'd be dividing by 0. We can't do that. So another way to go about doing this problem is if you really wanted to just go for the common denominator. Now, I didn't have to do it in this case because I could have set it up into a proportion. But let's say you wanted to, because there are problems which you really do want to do that. 14 and 10 are both missing that multiple of x minus 1 over x minus 1. So I would do that here, multiply them by it, and the 2 already has that. Now, because we're in an equation, and because we have a common denominator, we can now multiply both sides by x minus 1, and what happens is the denominator essentially goes away. So all that's left is now what's up at top. So now I have distributing 14x minus 14 plus 2 equals 10x minus 10. Subtract 10x, you get 4x. Combine like terms here, you get negative 12. And here you have a negative 10. Add 12, you get 4x equals 2. Divide by 4, you get x equals 2/4, which is 1/2. So we still get the same solution either way. Still the same thing with extraneous solutions. No other extra solutions were found, so we're good. Okay, number 6, solve 3x cubed minus 26x squared plus 16x equals 0. Whenever you run into something special like this, you get a cubic or a quartic or something like that, you have to imagine, at least for the time being, that there's something where you can get this into some sort of quadratic form. And one thing you want to look for is common factors, not just the numbers, but also the x's. Unfortunately, you can't divide these all by 3. This is the only number here that divides by 3. But you can divide out an x. And left hand side is 3x squared minus 26x plus 16. So in this case, either x equals 0 or 3x squared minus 26x plus 16 equals 0. Now, if you felt incredibly compelled to try and factor this, go ahead and try. I do believe it's factorable. If you did not feel incredibly compelled to do it, you can either complete the square, which is completely ill-advised for this problem, probably one of the worst things you could ever do, or quadratic formula, which is actually almost as big of a hassle because the numbers will be so incredibly large. Especially if it's a non-calculator portion of a test, You're not going to have fun with doing 26 squared. So you pray that it's factorable. And you have to work on the factors the way that you got to work on them. I'd work on them the way I work on them. And what I do is I say, choose my products of 16, 4 times 4, 8 times 2, 16 times 1. I know one of these numbers is going to be tripled because it's going to go over here, like 16 and 1, something like that. I know both numbers are going to be negative because a negative times a negative is a positive. My sum is negative here, and I'm going to start testing things. Like 3 times 4 is 12. 1 times 4 is 4. That only adds up to 16, or negative 16. I'm saying them in the positive way right now. So that's no good. 4 and 4 is out. Now, I do this stuff mentally, just so you know. I already see the answer now in my head, but I'll pretend like I don't yet. Let's keep trying. 3 times 2 is 6. 1 times 8 is 8. 2 plus 8 is 10. No good. But what if I reverse them? 8 and 2. 3 times 8 is 24. 1 times 2 is 2. 24 plus 2 is 26. Or really, negative 24 minus 2 is negative 26. So it looks like this one's it. This is the one that gives me that there. Again, when you distribute this, what I'm doing is I'm doing that, and that. 3x squared minus 24x minus 2x plus 16. These combine to negative 26x. So I'm checking in my head which one gives me that. The more you do math and stuff, the more you practice it, the better off you'll be at it. Instead of just following a process saying, well, I can't do that. Trust me, you can. I'm not saying you should do it immediately, but practice it. I promise you, it's a fun way to do it. But anyway, here you go. So either this equals 0 or this equals 0. And if this equals 0, x is going to equal 8. If this equals 0, x is going to equal 2/3. And those are your two solutions right there. Nothing extraneous. No issues like that. Oh, I'm sorry. And here's the third solution right here, that x equals 0. So 0, because I remember it's a cubic. 0, 2/3, and 8 are your three possible solutions there. Number 7, determine points of intersection algebraically. Okay, so by algebraically, I suppose you can do it with a graph. I suppose you can do it with a table. I'm going to go ahead and do substitution or elimination method. You have a lot of options here. This one is set up for elimination immediately. If I added right down the lines here, negative y plus y is 0. Those go away. X plus 2x is 3x. 3 plus 12 is 15. Divide by 3, you get x equals 5. Substitute 5 into one of these two equations. Let's do the top one. I'm going to subtract 5. Negative y is negative 2, so y is positive 2. So x equals 5, y equals 2. The final thing you should put is parentheses because this is a point of intersection. This is where these two lines intersect. You could have graphed them and you would have found that out. And one other thing you can do is substitution method. And with substitution method, all you have to really do is just isolate a variable. Let's say that I wanted to isolate this x right here. I just got to add y over. And this equation here will say, this equation here will say x equals y plus 3. What I can do is substitute y plus 3 in for x in this equation, and it'll say 2 times y plus 3 plus y equals 12. The objective is to get one variable by itself in one equation, right? So let's see, subtract that 6, combine like terms. You'll get y equals 2. And now the good thing about substitution method that I like is once you find one of them, you isolated this variable over here. Substitute 2. 2 plus 3 is 5. Very little work to be done after that. And you get back to your same solution set. It also would have been okay to isolate this y or this y. Isolating this x is a bit of a bummer because when you divide both sides by 2, this y becomes a fraction. And then when you substitute, you have to deal with a fraction. You'll still get the same answer, but be selective about which one you want to choose. The less negatives to me, the better. Number 8, state the shifts in transformations and then sketch a graph for this function. Okay, f of x, the same thing as y. So it comes in this form, f of x equals a times x minus h, quantity squared, plus k. All right, a is your stretch factor. H and k is your vertex, stretch factor. And h and k is your vertex. Okay, So our A value is -2. I'll deal with that in a second. Our vertex is 3, 4. So I'm going to start at 3, 4, right here. If my stretch factor was +1, I would go from the vertex, I'd go over 1, up 1, back of the vertex, over 2, up 4, etc. I could also reflect them across my axis of symmetry right here. Over 1 to the left, up 1, over 2, up 4, yada yada. And over 3, up 9 if I could. So this is what this would look like if the stretch factor is 1. If the stretch factor was -1, it would be the exact same thing but flipped over. So instead it would look like over 1, down 1, over 2, down 4. I could keep going. Over 3, down 9. I could go all day. Just like that. But the stretch factor is -2, so we know it's upside down. But the the 2 has to do with how far down I go. I'm going to double my previous distances. So instead of going over 1 and down 1, I'm going to go over 1 and down 2. Instead of going over 2 and down 4, I'm going to go over 2 and down 8. Double that distance. Instead of going over 3 and down 9, I'm going to go over 3 and down 18. Now, I can't really fit that down there, but that's what I do. Same thing on this side. Reflected across. All's good. And your graph, if you can do a better looking parabola than the one I'm going to do, then you are an artist. No, then it doesn't necessarily say a lot about you because these parabolas are awful. But there's the graph. You use this information to your ability. Didn't use a table. Didn't use a graphing calculator. State the shifts in transformation. Well, I kind of did. The vertex, you shift 3 to the right and 4 up. The only other thing I could say is it's upside down, and it's a little bit taller. How about that? That's a transformation for you. But the transformation is it flipped upside down. Okay, 9, A, B, and C all are graphs of that kind of same magnitude. So I'm going to talk about stretch factor just like that one, and shifts as well. F of x equals square root of x minus 3. So f of x equals a times the square root of x minus h plus k. Let's see what our values are here. A appears to be 1 because it's missing. 1 times this thing is just this thing. And I'm going to call it the vertex. Square roots don't exactly have a vertex. They sort of do. I'm going to start from there, though. 3, 0. Because x minus 3, h is 3. This one's missing. Must be 0. So I'm going to start at 3, 0. My stretch factor is 1, so it's going to react just like any other good old square root thing. I can take the square roots of the numbers 1, which is 1, 4, which is 2, 9, which is 3, but I can't quite reach there, so this is kind of all I can put. And that's it. If the stretch factor was larger, like 5, instead of going over 1 up 1, I'd go over 1 up 5. And instead of going over 4 up 2, I'd go over 4 up 10. So it'd just be taller. If it was negative, it would go upside down like that. No real transformations, just a shift. Transformations to translation. So I shifted 3 to the right. Shift 3 to right. I think this says enough about that. Personally, I think both of these things kind of do. Okay, g of x equals 1/2 x cubed plus 2. Okay, this is in standard form, sort of. Like, if I wanted to do any good old cubic function, it would look like this. Okay. Now, we're missing a quadratic term and a linear term, so all we're looking at is that. That's why I'm saying it's kind of in that form. But it's also kind of in vertex form, because what I could also say is I factor out this a here, okay, and all that's happening is that your h value is 0. If your h value is 0, then what happens inside here is it just looks like this. So it's kind of in both forms right now. This and this kind of now represent both the same thing. So this constant appears to be my y-intercept. This 1/2 appears to be my stretch factor, and I don't appear to shift to the left or right at all. So what I do have or know, at least for my vertex, whether you're looking at it in this form, in fact, let me rewrite it in that form fully. G of x equals 1/2 times the quantity x minus 0, then cube that, and then plus 2. So my vertex is at 0, 2. My stretch factor is 1/2. Okay, so you're going to have to deal with some fractions here, if that's all right. So we're starting at 0, 2, right here. Cubic functions. A normal cubic function is if I go over 1, I'd go up 1, because that's 1 cubed. Over 2, 2 cubed is 8. I'd go up 8. I'd go way up there. If I go over to the left, -1, -1 cubed is -1, -2 cubed is -8, -3 cubed is -27, etc. So your graph would look like this. This is with the stretch factor of 1. It would go terribly so. That's a cubic function like that. But if stretch factor is 1/2, instead of going over 1 up 1, I'll go over 1 up 1/2. 1/2 of 1. Instead of going over 2 up 8, I'm going to go over 2 up half of 8, which is 4. Instead of over 3 up 27, I'd go over 3 up 13.5, somewhere way up there. Something like that. I don't know. Actually, probably not that tall. Maybe about right there. I'll try and keep that one there just to have it graphed, because I think I can go down 13.5. Over 1 to the left, down 1/2. Over 2 to the left, down half of 8, which is 4. Over 3 to the left, down, because remember, -3 cubed is -27. Half of -27 is -13.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just off the map. 12, 13.5. That was good. Let's go ahead and graph this one now. And this is the proper graph for this. I'm going to try and go kind of slowly this time. Oh, man. It still doesn't look that great. That marking is nothing. Skip that one and go right on to that one there. And it keeps going. There you go. Tableless. Okay, one more. T of x equals 5 times the absolute value of x plus 2. In proper vertex form, we are missing our k value, which must mean that k is 0. So 5 times the absolute value of x, I'm going to put minus -2. X minus -2, this is as proper as I can make it, plus 0. So your vertex is at -2, 0. There's my shift, 2 to the left. Your stretch factor is 5. Now, absolute value acts a lot like slope, just depends on what side of the vertex you're on, because it's constant, but it changes sign. So 2 to the left, 0. This, instead of going up 1 over 1, up, 1 over 1, 1 over 1, we're going to go up 5 over 1. This stretch factor is like a slope. Up 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. Because ordinarily you'd go 1 over 1, 2, up 2, over 3, up 3, over 4, up 4. Well, we're going to multiply those distances by 5. On this side of it, we're going to go up 5 and over 5 this way. So we're just reflecting across the axis of symmetry here. And tip to tail, it's going to look like that. There you go. Trying to save as much time as possible on this thing just by describing it. Hope that's working. And that's all for number 9. I think that's all for graphs. Well, I might graph here. Find the standard form of a circle given the center here and a solution here. A solution means a point on the circle. Okay, a point on the circle. An XY value, if you will. What some people will do this with this problem, they might say, oh, I know my formula for a circle. I am given XY. I'm given H and K. If I substitute all these into here, I can solve for R. And you would be right. You can. So you can substitute -5 minus 3 squared plus 1 minus -1 quantity squared equals R squared. So that's negative 8 quantity squared plus 2 squared equals r squared. 64 plus 4 is r squared. R squared is 68. You may solve for the radius, but you might understand that as we are in this form right here, all we need to write are h, k, and r squared. We don't actually need the square root of 68. However, if you wanted to keep reducing that, square root of 68, the largest perfect square out of that I can think of right now is 4, and I think that's it. So that's square root of 4 times square root of 22, which is 2 root 22. That's a more exact, well, not more exact, excuse me, it's a more simplified value. Square root of 68, but we just need the 68. So your standard form of circle, x minus 3 squared plus y minus negative 1 is y plus 1 equals r squared, which is 68. And that's it. If, however, you are more of a visual learner and you are compelled to draw a graph with it, do something like that, what I would do is I'd go draw axes. I'd get, because this one actually gets you to understand what it is you're actually even doing. I get 3, negative 1 right down there. Negative 5, comma, positive 1 up here. Okay. This is the center. This is something on the circle. So the circle itself looks something like, let's do blue, looks something like this. Okay. That's your circle. So this distance is the radius right here. So we need to find that thing. We already have an xy value for, we already have our center for our final thing, but we need to find the distance from this point to that point. Okay, that's our objective right now, r. Now to do that, let me get the circle out of the way now. To do that exact thing, we have to find out how far down and how far over we go from these 2 points. Now this point is at 3, negative 1. This point is at negative 5, 1. We are going down from 1 to negative 1. That length is 2. We are going over from negative 5 to 3. That length is 8. Remember, this is a right triangle. This is vertical and horizontal. So a Pythagorean theorem would lead us to this right here. 8 squared plus 2 squared equals r squared. And of course, we are back down to here again. You solve for the radius, or just r squared, right? You solve for r squared, and you place these back in exactly as we did over here. When you find the standard form of the circle, you are giving them the information in this equation with h, k, and r. That's what we're looking for. And you have to know what solution means for this to work. By the way, the center is not a part of the circle. It helps describe the circle, though, its location and its distance, because that's how we found distance. We used the center for it. But that's your final answer. That's your final equation for it. Number 11, find the equation of the line given whose slope is undefined and passes through negative 8, 8. Well, they didn't really give us a line. We could draw it if we wanted to, but we're just trying to find the equation of this line. Well, let me just show you what this looks like in a drawing, really. Maybe it helps make more sense of it here. Here's the point, negative 8, 8. An undefined slope is a vertical one, or a line with an undefined slope is a vertical line, because it has infinite rise and 0 run. It goes this way forever, never runs, so you're dividing by 0, it's undefined. So we're just trying to find the equation of this line. And it's not a y equals mx plus b thing because you have an undefined slope. Instead, we actually don't even use the letter y, because what happens here is no matter what y is equal to, even if it's equal to 4, x will still be equal to negative 8. If it's equal to 0, x is equal to negative 8. No matter what you plug in for y, x will always be negative 8. So what does that mean? It means that x equals negative 8. And that's it. That's your equation. That's what these things look like. You can do x equals my plus b if there's such a thing. But your slope here is vertical. So this is all you got to say. That is the statement. That's all it is. Ta-da. Finally, number 12, use any method to solve the equation 6x equals 3x squared. Okay, I'm going to give you every way you can possibly do this. How about that? First of all, these are the only 2 terms here. They both have x in it. So one of your solutions is 0. You can multiply 0 by that. The only reason I'm saying that is because what I'm about to do for this way is I'm about to keep them exactly right here. And I'm going to divide both sides by 3x because I can. The 3's cancel out. X squared over x is x. 6x over 3x is 2. Here's your second solution. The reason why I wanted to make sure I got the 0 first is because I was about to cancel out that 0 solution. I didn't want to. So here are 2 of them. That's one way of doing it. Second way of doing it. I'll keep that there. Second way of doing it. Rewriting this like so. And I believe that every way I do it hereafter will be in this form. Rewrite it like so. And let's go ahead and let's try to do it in factored form. Let's factor out 3 and an x, and you're left with x minus 2 equals 0. So either, and now you can divide both sides by 3, because if we truly called this zero product property, we'd be saying we wouldn't be saying either 3x equals 0 or whatever. We'd say either 3 equals 0 or x equals 0 or x minus 2 equals 0. But 3 can't equal 0, so obviously that's not one of the conditions. That wouldn't even be a part of it. So we can divide both sides by 3, and you'll just say x times x minus 2 equals 0. So either x equals 0 or x minus 2 equals 0, in which case x equals 2. So that's solving by factoring. Okay? Third way is you can, and so I said the divide both sides by 3 thing. You can keep doing that. So I'm going to do that again. You can divide both sides by 3 and divide 0 by 3, get 0. You can solve by completing the square. So the third way I'm going to do is find out, whoops, there's no constant here, so I definitely don't have a perfect square. I got to find out what number gives me a perfect square trinomial here, and I'm going to add that over here as well. You take the number negative 2, we divide it by 2, that's negative 1. Negative 1 squared is positive 1. So we'll do 1 and 1. This factors into x minus 1 times x minus 1, which is x minus 1 quantity squared. That's equal to 1. Take the square root of both sides. Square root of x minus 1 squared is x minus 1. That equals square root of 1 is 1. That's plus or minus 1, though, in this case, because 1 squared is 1 and negative 1 squared is 1. We have to consider both cases. So x either equals 1 plus 1 or x equals 1 minus 1. 1 plus 1 is 2. 1 minus 1 is 0. Okay? There's that. Last algebraic one is by quadratic formula. And what if we kept it like this? What if we kept 3x squared minus 6x this time equals 0? We have a equals 3, b equals negative 6, c equals 0. Start off with the discriminant. We'll get b squared minus 4ac. Take a look at that. So b squared minus 4ac is just 36, because c is 0. Awesome. That kind of helps. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh my gosh. Uh-oh. X equals 6 plus or minus 6 all divided by 6. Ah! Beetlejuice, Beetlejuice. Oh, I'm not going to say that 3 times. The devil. Okay, here we go. X equals 6 plus 6 over 6. Or x equals 6 minus 6 over 6. Hurry, simplify. X equals 12 over 6, which is 2. Or x equals 0 over 6, which is undefined. Just kidding, which is 0. So there you go. There's that way as well. It's kind of it. I guess what you could do is you could also graph it. Like, not with the graphing calculator. I'm just talking about graphing it. Just so we can practice one more graphing thing, because I didn't mention negative b over 2a yet for the graphing one here in this video. Let's say that we graphed this thing. 1 second. Boom, boom. And what's going to happen here is we have our standard form. We're going to graph, so we have this right here. I'm going to graph y equals 3x squared minus 6x against y equals 0, which is the x-axis. I want to find out where they intersect. So basically, I want to find where they intersect on the x-axis. I want to find the x-intercepts. So I'm going to graph, though, y equals 3x squared minus 6x. One way of finding your vertex is by using negative b over 2a. So your b is negative 6, so negative b over 2a is positive 6 over 6, which is 1. Your vertex x value is at 1. The y value is the value of y when x equals 1. So you can substitute 1 in for x. And you can get 1 squared is 3, 1 times 3 is 3, minus 6 is negative 3. So your vertex is at the point 1, comma, negative 3. So it's right, let's see, let's use black. 1, 2, 3, 4. And then what I'm going to do is I'm going to apply my stretch factor and plot a couple more points. So we're at 1, negative 3. There's the vertex. Our stretch factor is positive 3. That's that a value right there. So for a quadratic, instead of going over 1 up 1, I'll go over 1 up 3. 1, 2, 3. Go to the left 1, I'll go up 1, 2, 3. Aha, look where they're intersecting. 0, 0, and 3, 0. Or 2, 0, excuse me. 0, 0, and 2, 0. Those are your x-intercepts. So we already know that there. If I kept graphing, instead of going over 2 up 4, I'd go over 2 up 12. And that's obviously way up here. I can't really get it for you. But that's what your parabola would look like with or without a graphing calculator. As you graph it, that's what it would do. So there you go. That was like 5 different ways of finding that. That's it. There is your practice test. Fiend!